My name's Tegan. Let me go to like a more friendly starting screen. Um, okay. My name's Tegan. This is an Intro to DevOps workshop. Looking to just cover over some basics about DevOps. I don't know if you guys have heard of DevOps before. Has anyone like heard at least the word before? Okay, perfect. Basically, it's a very big field and a very big topic. So it's hard to cover everything in one demo. So I try to pick the two things or three things that I find the coolest, which is infrastructure and workflows. Hopefully, depending on how fast we can get through this, I'll cover some Kubernetes basics at the end of it. Just sort of demo what Kubernetes is and like why it's useful in certain workflows. And yeah, so just to get started, was everyone able to do the setup steps that were sent in the ACM Discord? Was anyone not? Did anyone not do it? Okay, so I guess we'll just start through there then. All right. Let's see. So I don't want to spend too much time on this, but if these are the installations to get done, I didn't really set up like how-tos on these because I was hoping they would be done here. All right, if you guys aren't, okay, is anyone hoping to follow along who isn't set up yet? Because that'll make my life easier. Okay, I can give like 5 or 10 minutes if you guys want to try to like get these installations while I just talk about like what DevOps is and stuff like that, if that works. Does that help? Any questions? Okay, awesome. This page is also available on the ACM Discord if you guys want to look at it yourselves. But yeah, just go through these installations and I'll go through the optional part with you guys. So basically, like, what is DevOps? So I like to view sort of the software field as split into two main operations. You have the development operations, and then you have operations itself. So development is essentially, I like to think of it as a story-based sort of working process. So people will get stories attached to big projects, and they will have a certain amount of time to sort of complete that story within a designated sprint. So let's say they need to fix a bug or update a new feature. They want to just do as much heads-down coding to get that code out, or written and out there as possible. And then you have the operations side of things, which is sort of like firefighters. So it's very alert-based. You deal with things like security alerts. If a specific client has infrastructure issues or their databases are getting too full, they would sort of go in there and fix those and remediate those things as they happen. And sort of a process that started happening in the early 2000s is these development teams and operations teams started to clash a lot, and basically a development team would get very hindered based on the efficiency of their operations team. So let's say they push out new code, they have this new software they want to update, but there's no infrastructure for it. They have to communicate with this operations team to get that software pushed out there, or the infrastructure pushed out there, and it became very slow. So in the early 2010s, they started coming up with DevOps roles. You might have heard of an SRE before, or a site reliability engineer. There's system administrators. All those roles kind of go hand in hand. But the best way I like to think about a DevOps role is sort of a mesh between sort of like a 30 to 40% development cycle or operation cycle, and then the other half in operation cycle. So the workflow typically looks like dealing with some of these alert-based. So you might see infrastructure problems with one of your customers. So you would spend a part of your time remediating those, and the other part of your time figuring out how you can automate that process so you don't have to remediate that in the future. And so sort of the demo we're going to be going over in our class or in our workshop is setting up development environments. So a very common process once you get into real workforces is testing software, testing tools, and you need development infrastructure to be able to test that. And sort of setting this up manually can be a long process. And so we're going to show sort of how DevOps teams can create an internal application to sort of automate that process. I tried to keep the actual infrastructure that we're provisioning limited to a small EC2. That way, if you guys want to follow along, you don't get charged a bunch. But we'll see with the configuration, it's very easy to scale this to as many tools and cloud applications as you want to. So for those of you, who is planning to follow along with this? Okay, perfect. Awesome. Okay. So for those of you starting, first thing we would like to do is go to our AWS account. And we basically need to set up the method in which our code is going to communicate with AWS itself. So the easiest way to do that is to go to IAM. This is how you manage your access to all of your AWS resources. Hopefully Wi-Fi works well with me today. Okay. And then we're gonna go to users. I already have a dev user set up, but what you're gonna do is you're gonna go to create user. You can set it to whatever you want to, but this is sort of the user that your code is going to be taking over, essentially, whenever it's running this. Everyone following along well? Perfect. And then we just want to attach a policy directly. Since we're doing sort of a dev environment, you can add administrator access. I'll talk about sort of why this is a bad idea in the real world later on. But just for simplicity's sake, we'll go with this. And then we can create that user. And now you should have this test user here. And so now, to actually be able to gain access, you want to go to that user. Let's see. Might have to reference my notes here. Kind of forgot. Oh, yeah, there it is. And then you want to create an access key. And so this is how we're going to be, what we're going to be working with here. So I'm just going to do a CLI-based access key. I understand the risks. And then go next. Don't really need a there. And so now it's going to give you an access key and a secret. I try to set mine up prior to this, so I don't like accidentally show you guys, but I might do that anyways. So we'll go from there. Okay. Everyone good up to that point? Don't want to go too fast, but I also want to make sure we cover some stuff. Okay, perfect. So the first thing that we're going to do, I have a test demo here. So I'm going to try to start doing this from scratch, but I'm going to be referencing this workshop a lot. So I don't know if there's an easy way to copy this over. I'm going to post this in my setup docs if anyone has access to that. Okay. So there's going to be code in here that we're going to be referencing throughout our workshop. But for now, I'm going to go to our home, and I'm just going to set up a new repository for this. So here, I'm going to call this a test DevOps workshop. We want to make sure it's public. We'll get into that later on. And then go ahead and create that. Let's see. I think we're good. I like to create a basic README just to avoid some Git issues. Sorry guys, we're getting to the core stuff soon. This is just the necessary behind it. Okay, perfect. And now, I can't see all of mine. Perfect. I use GitHub Desktop. You can flame me for it if you like, but it makes my life easier. I will say that if you want to get into DevOps, it's very good to know the command line because a lot of places you can't really use GitHub Desktop, especially when you're working within virtual machines. But for now, we're going to clone that repository over. That way we can actually start working with it. Now we're going to open it up. Close this guy. Where are we at? Okay. I just want to make sure everyone who's following along has a chance to get to where we are right now. Does anyone have questions in the meantime? We haven't started much. Yes.
So I guess just to have a good understanding of what we're getting ourselves into, can you explain what each of these things that you want us to install before or not before, how will they be utilized?
Sure. I want to I have a bunch of notes on all of this for you guys to read later on. But yeah, so AWS CLI. That is basically the command line tool that you're going to be using to interact with AWS. So what we're going to be going over here is, have any of you guys actually had to build anything in AWS or GCP, start up a virtual machine, anything like that? Okay, perfect. So once you guys get into that, and I guess it's cool that you guys haven't gotten access to that, so that way this will be a bit more interesting. There's a lot of clicking involved, and it's kind of like corny, but in DevOps they call it ClickOps, and basically you don't want to do as many things as non-manual as possible. So all these tools we're going to essentially be using to make sure we don't have to do that stuff manually. I'll get into Terraform right here, actually. Is everyone good on setting up your repo? Anyone not good? Just want to make sure we're on time. We're 2 minutes in. Okay, perfect. So let's get into Terraform. So Terraform is going to be the first thing that we're covering today. So what Terraform is it is basically, it's called infrastructure as code. So it is a declarative language that allows you to define infrastructure within a code file. That way, you can essentially automate and control access to that infrastructure simply from a command line interface. So you don't actually have to log into AWS to be able to manage this infrastructure. And so a big part of this and how this works a lot is through something called state files. So Terraform essentially needs a way to know what infrastructure already exists. And so if you want to modify it in the future or delete it in the future, it needs to know what to access. And so Terraform does this via state files. And so in a local environment like this, all you really have to do is define the infrastructure, give it access, and then run it, right? But whenever you're working on a team of 10, 15 people, you can't really do that because multiple people might need to interact with this infrastructure, and they can't do that unless you publish these state files to GitHub or whatever your Git repository is, and that introduces a lot of vulnerabilities. You can gain access to access keys. People can copy your infrastructure from there. It's very dangerous. So the first thing we're going to be doing here is creating a remote host for the way we're going to manage our infrastructure state. So I'm going to make a folder here called State Bootstrap. I misspelled it. Yes, sir. What's up?
I don't get this README
The
file.
README? So README is basically I think it's in all Git-based repositories, but it's essentially a way that you can write a brief description on what your repository is. So if I...
Does it come automatically or do I have to do something?
Oh, I just added it for, because my computer gives me issues if I try to clone my repo without having a file in it. So this is optional. You don't have to worry about that. And so starting off with our first Terraform structure, Terraform evolves on three main types of files. You have your main.tf, you have your variables.tf. Oh my gosh. And then you have your output.tf. So main.tf is where you actually declare your infrastructure. So I'm gonna start moving a little faster, that way we can push through this. If you guys have questions, feel free to stop me. So how do we manage the state, right? We need a central place where we can access our infrastructure. So what we're gonna be using here is Amazon S3. It's basically a way to store objects inside of your cloud. So anyone with access to that S3 bucket can reference the state. So the first thing you need to do in Terraform is define your provider. And what this does is it essentially allows you to tell Terraform what you're going to be talking with. So it knows what configurations to look for, what credentials to look for, and things of that nature. Perfect. Okay. And then the second thing is we need to actually declare, it already knows what I'm trying to do, which is funny. But the second thing you need to do is declare your actual resources. So in this case, I'm going to cheat and hit tab. So we're defining a resource called AWS S3 buckets. Now, there are thousands of resources you can go here. I recommend looking through the, yes?
I can't really read it from back here.
Does that help? Perfect. Awesome. We're going to get rid of access control lists because that is deprecated right now. And then here. So in a real world instance, versioning is extremely helpful when you're managing state files because let's say you have an intern who goes and updates your infrastructure and it screws everything up. Versioning allows you to reference your previous state and sort of revert all of your Terraform and infrastructure back to how it was. Okay, so let's get rid of versioning for now, just because there's a different way to do that that's a lot more secure now. And then prevent destroy, we're not going to utilize this because we do want to destroy it when we're done. That way you guys don't start getting charged. Let's see. Let me make sure I have the correct configurations here. Okay, yeah. and force destroy is true. Basically, S3 gives you some issues whenever you try to destroy it with Terraform. But since we don't want this to be persistent, we're going to end up doing that. And then the next thing we want to set up is a lock table. So Terraform lock is essentially a way to make sure that multiple infrastructure changes don't happen at the same time. This is very important in DevOps because when you're working on big teams, especially at bigger companies, multiple people might be trying to make infrastructure changes at once. And if that clashes, it can really break and crash everything. So by managing a state file, you're basically able, or a lock file, you're basically able to upload like, hey, this Terraform lock is enabled, so nothing can affect it until it's done. And so for that resource, we are going to be creating a AWS DynamoDB table. And then we are going to name that just a state lock table. And so these extra names you see right here are essentially the way the variables that your other infrastructure can reference these resources that you're creating. Yes?
So this Terraform stuff you're doing is creating the buckets, not like referencing ones that you're
Correct. Terraform is basically a way to create this infrastructure. So rather than having to go into AWS EC2 and sit here and manually try to upload all of these S3 buckets, that's really something you want to avoid in production environments because it's a lot easier to make mistakes in that regard. No problem. So here, let's see. I am going to, we're not going to use secondary indexes. Perfect. And this is more just DynamoDB specific stuff, but essentially what this is doing is just adding a lock ID to each instance that we create of our infrastructure. And this is a bit less, you'll see this later on. And so now, we should be pretty set here. We're not using variables right now because our setup is pretty simple. We're doing it locally, but I'll get into variables a bit later on. So now that we have just this is really all you need to start up a Terraform or infrastructure. So I'm going to open up a terminal. And now, the very first thing, and any cloud-based interview you're ever going to get is normally going to ask you this question, is when you run Terraform, what's the first thing you do? And that's Terraform init. Basically, Terraform doesn't know what to do unless it knows what your environment looks like. So if we run Terraform init, it's going to sit here. Oh yeah, forgot to mention. Terraform only runs with the main file that's in your current directory. So if you're not in the directory, if you're not in the directory and try to run it, it's going to give you issues. But this also lets you separate different infrastructure types within a same repository. So now that we're here, we can Terraform init. And this should work fine. There's a big flaw in our current code that we're about to encounter soon, but it should not affect our inits. Okay, so here you can see that we're creating our .terraform file. This is the metadata that Terraform uses to reference itself, essentially. And then it's going to create our lock. So this is how it manages a lock locally. Since we don't have this remote infrastructure yet, it needs to reference this locally. So that's sort of like the source of failure for Terraform is how you actually provision the things that manage this. Okay, so now we got this started up. I'm sorry?
I'm getting the same initialization is not possible. It's an empty directory.
Yeah, so do cd space and then the state bootstrap folder. So it changes directory to your state bootstrap folder. And then you can run it from there. Okay, perfect. And so now what's going to happen is you can run something called Terraform plan, which essentially lets Terraform show you what infrastructure changes are going to be made. And you're going to see here, we're going to get a pretty bad error. Hopefully, if it works, it actually might work because I haven't reset my environment. Okay, perfect. Awesome. So you can see, and this answers your question from earlier, is we don't have the credentials here. Terraform tried to access AWS, and it's like, hey, I can't actually make anything, right? And this is where this information that we made earlier comes in handy. So what we're going to do here is I'm going to make a .env file. I guess you guys are going to end up seeing my stuff anyways, so it's fine. I actually might be able to just copy that. Okay, so in our .env file, we're gonna have our access keys. I'm gonna delete this after the workshop, so don't try to steal it, please. Before then. Okay, so this, we're gonna export AWS, and the names of this are very important because this is the standardized version. So AWS access key ID, that is going to be this access key that you made when you made your key. Secret access key is going to be this, and you're gonna copy that over. If you've already exited this page, you need to reference your CSV file. And then we're gonna be working with US East 1 as our default region. And so what this lets us do is we can run source.env. We have to go back one directory since we're in our state bootstrap right now. And that will essentially populate our environment to be able to reference those AWS credentials. We can do env, and you can grep for AWS underscore, just to make sure that those actually got modified. Okay. Everyone good on what we're doing so far? Does anyone understand why this is very important? And this is also why it's crucial to make sure you have proper permissions in a production level environment, because if anyone were to accidentally leak these keys like I just did right now, they can pretty much do whatever they want to all of your infrastructure. Yes?
Step back for a moment. Did you go over how to get those keys?
Yes. In the setup, it is this section right here where you configure an IAM user. You go to create user, attach policies, administrator access, then create. And then you want to create your CLI key through there. And there's steps for that as well. Okay, perfect. So now if we run Terraform plan, it shouldn't give us many issues here. Perfect. So now you can see that it's looking to create an S3 bucket called state bucket, and then it's trying to create a DynamoDB table as well. And this is telling us what's going to be created. So now we can do Terraform apply. And this is the command that will actually make your infrastructure on your AWS account. So this is the big command, this is the dangerous command. This is the one that you want to get double checked before you run in a real world. It'll ask us to double check. Here, it tells us the plan output, so you don't technically have to use Terraform plan in the future as long as you approve it. And so we're going to accept that. Oh no. Oh yeah. Okay. So this issue is because our ChatGPT generated code gave us my unique bucket name, which is already taken. So S3 buckets have to be unique. So here I'm just gonna go into TS state, Tegan dev demo or whatever. So there's something random that's unique, and we're gonna be referencing in the future. So you don't have to make it as long as mine, but anything that's gonna be unique. Terraform apply. Any questions while this runs? Terraform's kind of slow.
Sorry, how did you point to that .env file?
So I added export at the beginning of our commands here. And so the source command essentially just can run that file. So when I do source.env, it essentially runs these 3 lines, which adds those environment variables to my local environment. So that way, whenever Terraform goes and runs, it uses my environment to run. And so it can see, okay, I have these access keys to reference. And we'll show a different way, a more secure way to do this later on, right? Yes? Perfect. So now you can see apply create. Resources have been added. So now what happens is, if we go back over to our infrastructure here, and we go to S3, you can see, and I have one from earlier today, you can see that TF state Tegan dev demo has been created, and our lock table has also been created here. Perfect. Okay. So why is this useful? Why are we just doing all this stuff, right? So now we're going to try to build something that actually references these state files and shows off why having a remote interface for these is super helpful. So what I want to try to build here is a very, very lightweight front-end application that can essentially take in a user's inputted variables and make infrastructure based on that. So let's say you're in a company and you have an internal software where you want to be able to spawn up a dev instance, but you don't know what size you want it to be, what type of instance you want to be, what region you want that instance to be in. This will allow you to sort of input those specific variables, type it in, and then infrastructure is created just like that, just through a simple one-click infrastructure automation. So in order to do that, we're going to create a folder here, and we are going to call this, we'll call this our info bootstrap here. And this folder can be named whatever you want to. The names of these don't actually matter too much. And the things we're going to do, we're going to make our main.tf, we're going to make our variables.tf, and then we're going to make our output.tf. And so now, we have to think, well, what is the first thing we have to do on our main.tf file? Anyone remember? Nobody? Perfect. We have to make sure Terraform knows who we're talking to, right? So we create our provider, we go AWS, and then add that here, okay? And so now the next one is, what are we trying to create? What is the infrastructure that we want to be built when this script is run, right? And so what we're doing right now is we're just trying to make the EC2 that is going to be provisioning our infrastructure, right? Things can get very abstract here. It's a little bit hard to keep track, but so ask questions if you need to. So the resource we're going to make is just AWS instance. And we're just going to call that our web instance. Actually, we'll call that our infra provisioner. And then we're going to add that here. We're going to use a T2 micro. This will just make sure that you stay within the free limits of AWS. I try to keep this to where you guys won't get charged. And then add this to infra provisioner. So what is this AMI, right? This AMI is essentially referencing what image we're going to be creating. So what I'm actually going to do here is I'm going to create it as a var.ami ID. And what this does is it will actually give you an error if it doesn't find the appropriate AMI ID. And this is where that variables.tf comes into play. So now I can add in a variable here, called variable AMI ID. I'm going to try to speed up. I don't want to talk about Terraform this whole time, so it's not just a Terraform workshop. Okay. And then I'm going to copy over the Ubuntu one from our infrastructure here. You guys can copy that over if you'd like to. So, let's see. I just want to take a poll here. Do you guys want me to keep doing this manually one by one? Or do you want some copying and pasting to speed up to the later portions? Copy pasting? Okay, perfect. I didn't think it would go this slow. I apologize. So what I'm going to do here is I'm going to steal this information for the key pair and the security group we're going to be referencing. Basically what this means is this is essentially the things we're going to be adding to our instance. So whenever you make an instance and you want to modify sort of how you access that, you need a key pair. And then if you want to make sure you have certain security measures to be able to access that, right here we want to be able to enable it so we can actually SSH into our EC2 with port 22 and then access that on port 80. Because that's where we're going to put our web location. And then egress 00-1, this should make sure that our EC2 can access any IP address from any port with any protocol. So speeding this up here, I need to make sure I have all the right information here.
I have a question.
Yes, sir.
Why are we doing it in a different folder? Why are we not updating the previous main.tf to create TCP instance?
That's a great question. So, the way that Terraform manages state files is, so the plan for this infrastructure that we're creating is to utilize this remote S3 bucket that we made earlier. So what this code is doing right here is it is making our S3 backend. So it's creating the backend that we're going to be used to host all of the Terraform info that we're going to be using, right? And so what this file is going to be doing is provisioning an AWS instance. So the reason you separate it is so that Terraform knows that it's two completely different sets of architecture. this state bootstrap is technically only referencing itself. It's referencing these local files versus this is referencing the information that's in our AWS account. Does that make sense? Is that too much? Sorry. Okay. We have Varda AMID.
But even we, I think, even for DynamoDB and the S3 bucket, we were using the same AWS account information.
We are, yes.
Why are we treating them differently?
I'll show you just in a second. I'll add something here. So for key name, we're going to be referencing here. And then I need to add in a deploy key.pub. This is going to be the key that I'm going to be adding into our account. And this is just your public key for whatever SSH key you created. That way you can access your instance. Path module and for key we're going to be using deploy key.pub. Okay, so we should be good here. So you asked why are we referencing this separately? So there's actually a fourth Terraform base here called backend.tf. And what backend does is it allows us to tell Terraform where to host all of the backend. So I'm trying to think of a good way to like explain this. I'll copy over our bucket here. Basically, imagine Terraform as keeping a chest of all the stuff that your infrastructure needs and has, right? And if I want to delete something, I can take it out of that chest, and if I want to add something, I can put it in that chest, right? This file right here is essentially building us a chest, right? And in order to reference this chest, we have to reference it in this backend, right? So if we try to update this code to have this backend, it doesn't know where to look because that is what makes the chest. Does that make sense? So we're basically trying to separate sort of what creates the stuff that holds our infrastructure and our infrastructure itself. You don't want those to become interlap because eventually we're going to delete all of this infrastructure, and we don't want that to affect our the thing that manages our state. Okay. Oh man. Okay.
So maybe we are going to cross-reference these two Terraform states.
Yes. So we're uploading all of our state to AWS. That way, if any one of you guys wanted to update my infrastructure that I create, you can update it from your computers because all the Terraform information is in AWS. If you wanted to change the stuff that's in our state bootstrap file, you can't do that because all of our Terraform is inside that folder because nothing's been created yet. So I am going to skip forward a little bit to hop over to this repo. So hopefully just try to show off what we were attempting to build there. Let's see. Okay, so I guess the big question is like, why have we spent 30 minutes on Terraform in a DevOps workshop? Well, the reason that this is super important is that in DevOps, infrastructure provisioning is sort of a core component of what you're going to be doing. And so knowing how to properly sort of provision infrastructure and how this works in corporate environments is very important. Any infrastructure that you're going to work with in your entire career is normally referenced just like this. This is how it's been created, this is how it's going to be destroyed, unless you work at a company that doesn't know what they're doing. So in this situation, what we're doing is inside of our instance here, we have an initiation script. So what this is doing is this is essentially a setup script for this instance that we are creating. I'm not going to bore you guys on the details here, but it's basically creating a Flask application, adding it as a system daemon, starting up that Flask application, and then reverse proxying it with Nginx. That way we can actually like see the app, right? So hopefully I should be able to just run this here. Terraform init. We have to start this up. Oh yeah, I have to rerun this. So now we're starting back from where we were. We have to provision our state infrastructure for this. Perfect. And then CD back over to our infra. So now we initialize it. We're initializing the back end. Oh my. Give me a moment, please. Basically, the error there is that we're referencing the wrong backend. Perfect. We've initialized it with that state that we created. Now we're going to apply. I use auto approve. Don't do that. It just makes it faster. So while that is provisioning, let me think. I guess I can show off something else. Okay. So have you guys ever heard of what a workflow is? Does anyone know what a workflow, CI/CD pipeline? Raise your hand. Awesome. Has anyone here had to work at an internship before? Or deploy code at like any sort of company? One? Just one? Okay. If you are planning to get into software engineering, the number one thing you're gonna face every time you push code is rejections. Because you're gonna push your code and it's gonna say like, hey, this is bad code, right? And what this is doing is it's basically preventing your bad code from getting out to production. And so a lot of people might think like, how does this actually work? How can we test what bad code is before it even gets out there, right? Because you don't want this code to get hit production before you sit there and worry about it. So what different companies do is they use these things called pipelines. And so GitHub uses those via workflows. So right here, what we have is the basic rough code linting. And essentially what this does and what workflows are is it is a pipeline of steps to pass code or anything of that nature through before you essentially push it. So the basic Git workflow is you develop something on your own branch, and then you eventually push that to a main branch, which is public. Does that make sense, everybody? Is that more familiar? And so what we can do here is most companies have something called a dev branch, right? And so you have to push the dev branch before you can push it to main. And what we can do is we use something called rough that can essentially perform a static analysis on the code that we are pushing every time we push that code to dev. Yes?
Can't see it though.
Oh. Is that better?
Yep.
Perfect. And so what this workflow is doing is it is saying, on a pull request to our branch called dev, we're going to run these jobs, right? And so jobs can encounter a whole list of things in the real world. In this case, what we are doing is this is essentially creating something called a runner Some of them run on Docker containers, and it's basically acting as if it is a human being sitting there testing your code. And so what rough does is it references your Python code to a set of standards. So what we can do here is I can come in and I can create a file, and let's just call this a badfile.py. And I'm actually going to switch over to a new branch here just to show this off. Just give me a moment, sorry. Holy, okay, that's why I'm in the wrong. Okay, so I'm gonna create a test branch right here. And then I'm going to create that dev branch that we're gonna be merging into. And so the basic workflow of how a pipeline works is whenever I'm creating or coding a file, right? So I'm going to say this is a file that, or a thing that takes in a name, an age, then we're taking, I'm pretty sure I have bad code in this repository already, so I don't really have to do this. I'm going to use a basic comment. In Python, you want to try to stick doc strings. And then in our main file, I'm just going to do def main and then have that print out. Perfect. And so now we're going to see that if we go to merge this code into our actual branch, we have this pipeline set up that's going to test this code. This is an automated way to do static analysis of this. So we're going to commit this. We're going to push that to our origin, which is just pushing it to Git. Create a pull request to merge this. Oh, I'm in dev. That's sad. Okay. Whatever, let's just try this. Okay, so we're going to create this pull request to try to merge it in. This is a very common process. Normally it's going to be a much bigger file depending on what you're updating within your repo. Create that. And you can see we're able to merge. There's nothing really wrong with our actual push. But now you can see it automatically runs this check that we have written in our workflows. And so what this is doing is it's making sure that our code actually passes these checks before it gets pushed. So in the real world, you can see that you can put this as security scanning, making sure that your code is actually secure. You can run those through different tests. I know one of the things that I had to build in my first DevOps internship was essentially building a workflow where every time a new version of our software was pushed to production, it would use this workflow to create an environment to actually spawn up our software and pull in the versioning and then create changelogs on it. So there's a whole list of things you can get into. But the basic premise of this is being able to utilize simple YAML files to automate different checks on your code before it gets. And this is something that you build a lot of whenever you're working. And yeah. So now, our stuff that we built earlier should be set up. Let's run this over. This is incredibly slow. I apologize. Okay. We have our info here. Should be bigger public, yes. Now we cross and pray. That's terrible. Okay. I apologize, folks. I put a lot of work into this prior, and this is not going as well as I had expected. But if you guys want to see what DevOps really looks like, this is what it looks like. Building something that you think is going to work perfectly, and then when it matters the most, it fails, right? And so now you're on a time crunch to be able to fix this properly, right? So live here, we're going to see if we can go in here and try to fix this. So right now, we're getting a bad gateway. This can be a whole host of issues. It's not very descriptive. So what I'm going to do here is I'm going to SSH into our server and see if we can figure it out. So I'm going to reference my .sh. Oh no. .sh, and then go to my deploy key. And so now we're in. So I'm going to use something called journal control. Since we're running our application on a daemon, this is a really easy way to take a look at our Flask app. I think that's the syntax. No? Let's see what this bad boy's called. It is called Flask app.service. Okay. Oh, it's not service, that's why. Okay, let's check it out. Absolutely nothing. Changing the cresting working directory failed. Maybe use system.exec. Okay, I think I know what's happening here. So if we go over here, basically what we try to do in here is we try to get clone from the user to do, because I wanted this to be editable for you guys, and I didn't change it when we ran our script. And so now if I change this to Tegan Smith, now I can show you. So this is the initiation script. So this is the script that we want to run on startup. So it failing is bad because now we have to recreate all of our infrastructure because this failed, right? Well, lucky for us, Terraform has something called Terraform Destroy, where all I have to do is run that, and it will use those state files that we referenced earlier on to look at all of our infrastructure, see what exists, and then be able to destroy it. So if I hit yes, now it takes down our EC2, it takes down the IPs that we provisioned, it takes down the security groups we meshed out, and this becomes super helpful whenever you're onboarding clients for real-world SaaS, because you're going to have load balancers, you're going to have databases for them, you're going to have EC2s, you're going to have clusters. You can have thousands or hundreds of thousands of dollars of infrastructure just based on what client you have. And so missing any of these whenever you're trying to take it down can cost your company thousands or hundreds of thousands of dollars in the long run, right? So it's very important they are able to take down every single piece of infrastructure whenever you are performing a full takedown. And Terraform is essentially a way to automate that whole process, which is sort of the use case of what we've just built so far. So that is destroying.
Sorry, excuse me.
Yes, sir.
Are there any other, I guess, products like Terraform or like software that companies use?
Of course, yeah. So Terraform is the biggest one, mainly because it's cloud agnostic. So you can use it on anything. It works with so many different things, and it's very simple to use. I'm gonna push my code, my updates real quick, just to make sure that we're good. Sorry, I'll finish your question in 1 second. Just want to get this on the run. Okay, yeah. So you have, and there's also something called AWS CloudFormation. So for companies that have a full AWS architecture, CloudFormation, so you can see all this work we had to do to essentially manage our state. We have to create S3 buckets to be able to reference that. We have to reference that locally. What AWS CloudFormation does is if all of your information is within AWS, you don't have to worry about the state at all because AWS essentially knows where everything's at. And what's cool about AWS CloudFormation is you can use something called the SDK to actually reference this infrastructure with something like Python or JavaScript. So rather than having to sit here and use a declarative language like HCL, you're able to do that just in your JavaScript applications if that's how you want to provision the infrastructure. There's something called Ansible, which is how you can actually provision updates or configurations on a wide range of technologies. So I know at Southwest Airlines, you have a bunch of different airports all over the country, right? And if you want to update a certain router, right, you don't have to have someone go in person and manually update every single router. So what you can do is you can connect Ansible playbooks, set up that configuration, and then push that out to every single router that's out there. So basically, the core of DevOps in that regard is you're taking something that physical infrastructure people would have to do manually in the past on every single server they provision, every single network interface they work with, and use basic scripts like HCL or Terraform languages, Ansible, and things like that to automate it just from a single computer. So now one DevOps engineer can manage the infrastructure and configuration of infrastructure that took 100 people in the past. So that's really where these things start to shine. I am going to see here if this is now working, ideally. We have 8 minutes. That's not an issue, don't worry. It's scary, but it's fine. Go to our new infra. And you could see there that our old infrastructure was terminated just through the command line that we were using. And if I reference this, cross our fingers and pray that we don't get a bad gateway. And we got a bad gateway. All right. Brother. Okay, I'm going to pivot here just for a second. And I guess try to get a little more sustenance for you guys. You don't know how long I spent making that work properly, by the way. Being able to automate infrastructure provisioning, just to not be able to show it off, that's very painful. Okay, so what I have here, I didn't want to include this in the original demo, but it's basically a mock Kubernetes instance. So the issue with Kubernetes is that it's very expensive. So just to spawn up, I'm using this little mini cube here, which is basically the cheapest version of Kubernetes that you can do. And even with that, you need 2 virtual CPUs to be able to run it, which is outside of the free limits for AWS. So here, let me see if I can connect to this guy. I might actually have a service running, do I? Has anyone here ever heard of Kubernetes? Has anyone ever had to use it or know what it's used for? Okay, perfect. What do you think is like the most important part about Kubernetes? Curious, not to put you on the spot.
I think it's resilience, probably.
Okay. Perfect. So what does he mean by resilience, right? So let's say you have an EC2, you have a virtual machine, right? That is hosting your application. What happens if that application crashes? Anyone know? Pretty simple, right? You're pretty screwed, okay? And now your entire infrastructure relies on you getting that single EC2 backup. And some companies do this by having multiple EC2s or virtual machines and then using a load balancer to balance those loads to all 3 of them. But that can get expensive because you're having to provision entire servers for this. So with Kubernetes, what you can do, let me see if I have everything. Okay, perfect. So what you can do with Kubernetes is you can run these things called pods. And what pods are is essentially containers that mimic the services that actual virtual machines would be running or servers would be running. And as you can see here, we have 4 pods of quad running. And I don't know the correct term for this, I don't know if you can correct me, but you can almost think of these as like replicas of each other. So they're all running the same service, and they're all running the same thing. And they're all, like, you can think of them as pretty much synced. So if I can do this properly, I'm going to spare, oh, wait. Okay. That's what it's supposed to look like, the old one, by the way. Workshop notes. I have to do a special thing here because I'm running it through localhost rather than hosting it on an actual port, because I don't want people to ping it. Whatever, we'll just... Okay. I guess I'll do this. So we have 4 pods here, right? And I am going to try to essentially nuke these and delete these as fast as possible. So if all 4 pods of these go down, the service goes down. So if I go here, and I port forward this to local 80. Is it already up? Okay, perfect. So pushing through here, this is just a basic Kubernetes application that can give us information on different probes and different information about our cluster. The actual application itself isn't super important here, but what we're able to do, ideally, is I can go in here, and our service is running on one of these pods. And if I come in here and I just completely delete that pod, right? There's no need to specify resource type. Okay. So now that pod's deleted. Well, if you go back here, our actual thing, like, gets interrupted. Let me see. But if I reopen that up, this is why I was trying to do that thing earlier. But if I just reopen that port forward, our application actually still exists, right? So when you have this load balancer, like, no matter how fast you try to delete these, things are still up. So if I try to delete all of these applications or nodes, so do kube control. I delete that. I delete this guy right here. You can imagine this as a DDoS. You can imagine this as it crashing. Really, however you want to think about these pods going down. And I'm going to save you the time is the fact that you can't delete these fast enough, because if I go and I try to get my pods again, all 4 of them are still running, because the second a head gets cut off, it's like what are like the Hydra. Like, they just come up like every time. So, like, Kubernetes is very hard to take down. Whenever you're trying to, like, update on this, it's very difficult because you have to start from the very ground up. If I try to replace something with one of these pods because it's misconfigured, it's going to keep spawning up. And the way this is actually managed is something called a deployment. So that entire application is run through this single YAML file. So if we open this up, what this is doing is it's setting a deployment. So rather than spawning up an application on an EC2, it's like a daemon or something like that, you can spawn this up on Docker containers like this, and you replicate that within a Kubernetes deployment. And here we're using 4 replicas, which essentially means that 4 of those are running at all time, and if any one of them ever goes down, it can just switch to the next one. And if one gets too many resources and needs to swap up, it goes to the next one. And yeah, that is essentially, like, I think those are sort of the core technologies that you would interact with in DevOps. I had a lot of hiccups here. This is my first, like, big live demo, so I apologize that some things like this did not properly go right. You can see my old instances here. If you look at basically what we're able to do is you're able to provision new infrastructure just by sending this here, and then you're able to delete these as well. And I was able to spawn up 10, 15 different applications. And all of that is run simply through, just to give you guys a rough overview before you leave. Through a simple application here I think I just actually just saw why everything was crashing, but that's fine. Because what you're able to do is the reason these variables files comes into handy so big is because you could send it TF-vars files, and as long as it matches the actual formatting of your variables.tf file, you can modify that infrastructure for configuration no matter how you want to. And you asked sort of why the state thing matters, is because we have this remote version for a state, we can now reference that to create the state files for 10, 15 different EC2 instances, versus here we would have to create these directories for every single one of them. And one of the big things here is if you try to create this in this file without referencing that backend, what's gonna happen is Terraform is gonna see that new EC2 and be like, hold on, this looks different from our infrastructure that we remember. So I'm gonna modify all of our state backups to match this, because this is actually what it looks like. And so now all that infrastructure that we created originally gets lost. So if I were to create 15 EC2s, our Terraform is only gonna point to the newest one, and all 14 other ones are just gonna be like lost in the midst. But they're still gonna exist, but it's gonna be very hard to delete those in the future. And yeah, so having that backend allows us to provision an infinite amount of infrastructure and be able to manage it synctually for as long as we need to. And it makes the sort of spawn and destroy process extremely simple. I think that's all. Yeah, and you can see here, I'm basically just using that form, the HTML form that we're getting to get the region, instance type, and client name. I'm creating that TF-vars in a temp directory, using that to pass it into our Terraform as a -var file, and then just applying it with that -vars file, and then it provisions up, and then we can delete it and manage it from there. One last thing that I wasn't able to get to because our app didn't end up working properly, and one of my favorite use cases of workflows is code deployment. So whenever you're running an actual application, and I'll try to wrap this up quickly, sorry. Whenever you're running an actual application with code, that code has to be hosted somewhere. And so simply pushing it to a GitHub repository isn't always enough to like actually have that hit users, have that be usable. So a simple workflow like this, what this is doing is it's able to, on any update to our application here, we're able to use this workflow runner to SSH into our instance, use GitHub secrets to reference the host and the user in that SSH key that we created earlier. And it's able to go in here, pull that, or git pull that origin or whatever code we just updated, and then restart our application. And so the way this looks in practice is essentially just by merging my code into main here, in about 3 or 4 seconds, our code is now fully up and running on our actual service. And this is sort of how you'll see, my computer died, so. Force ending of the DevOps workshop right there. Oh yeah, no worries. But yeah, that wasn't as smooth as I hoped to go. I try to just knock out as many like overviews of technologies as I could. DevOps is hard. I find it really fun. It's one of those things that you either find really fun or extremely boring. So if you found it extremely boring, I greatly apologize. Does anyone have questions? Does anyone have like concerns about like sort of anything about the importance of it? Any more like conceptual topics that you'd like to hear about? Yes.
If I am not planning to be a DevOps engineer, but I want to know sort of like basic DevOps stuff just so that I can, you know, do just like the basics that would be great for me, like Terraform, being able to create AWS instances and like just do all that super easily looks really awesome. What kind of other things should I have in mind? Just like for myself, if I'm building a project, but I'm not planning to be just like a full-blown DevOps engineer.
Yeah, I think ideally, if you have good DevOps engineers, you never really hear about it. It sort of all happens in the background. So I think the biggest benefit to knowing what DevOps is knowing what's actually happening in the background, just to be more knowledgeable about things you're building. Things like workflows and all that stuff. A lot of this stuff happens in the background when you push, and all you see is what you need to see, right? The things that I think would be super useful for people to know is I love using Terraform for dev instances. I think it's a super good thing to be able to do. I think knowing how Terraform provisions infrastructure, I think once you get past like the small learning curve, it's very easy to do. It makes it very easy, especially when you're working on multiple projects. I use it for my personal projects because I have like 6 AWS accounts. That way I can stay within free tiers. And if I forget about infrastructure there, I can get charged later on, right? So things like that. I would say knowing how workflows work. I know a lot of software engineers that have to build workflows themselves. So knowing how that process works. And then I think learning Kubernetes and how Docker works is one of those things that DevOps engineers work on a bit more. But depending on your company, even if you're developing software, you might be developing Kubernetes-based software. So if your software is going to be running on Kubernetes, it's good to know the benefits of it, why it's useful, and sort of how you separate the architecture. Does that answer the question?
Yes.
Okay. Does anyone else have like questions? Nobody? Any concerns? Or anything like that? Did anyone get something of use out of the demo? Because it didn't go like as smoothly as I wanted to, but I want to make sure people like actually like saw something to do with the technologies that we were using. Okay. When you guys think of DevOps, is there anything that I didn't cover that you guys would like to know about? Yeah.
I guess one thing I usually hear a lot is like usually downtimes and or like any issues that might come up from like like running updates. Do you guys run into any of those issues? And if so, like how long are those downtimes and how quickly can you get things running?
Yeah, so
Understand everything correctly?
So stuff like downtimes, I think that's really cool because that's where like the development and operations part merges for DevOps, right? So downtime is typically an operations issue. So operations people, like systems administrators, are normally the ones that go in there, and most downtimes are a result of some sort of resource being exhausted. So it's either a database is full and things start crashing, or your CPUs get maxed out. The way DevOps comes into play here is by implementing tools like Kubernetes or things like that. Because what Kubernetes allows you to do is it makes it to where if those, and one of the parts about Kubernetes I didn't mention in there is that if it gets too big, you can configure it to add more nodes. So we only had 4 nodes, but what it can do is be like, hey, all 4 of these are full, let me make a 5th one, right? And it could be an emergency thing or things like that. So DevOps sort of takes those situations like that where you might have those downtimes or those crashes, and developing code or tools that can essentially prevent those from happening in the future. Things like Terraform are super useful with that as well, because in that instance where let's say a database gets maxed out, if we want to fix that, I'd have to go into AWS, manually configure and update that the database to double its size or whatever, and then I have to go into all the different pieces of it that might be impacted by that change. With Terraform, you saw we can configure, for example, we configured the AWS to have an ingress run on port 22. If I wanted to edit that to be port 43, I can do that and it automatically updates on our code. So just by going into that Terraform and changing our database from 20 gigabytes to 40 gigabytes, and then hitting Terraform apply, we can make that application get fixed in a minute or 2, rather than the 10 to 20 that it would take if you had to do it manually. So it's sort of about, yeah. I was gonna say, it's sort of about building the tools to prevent stuff like that and make those situations faster, rather than sort of encountering them ourselves, if that makes sense. Yeah.
One thing I want to improve on for like myself and my projects is unit testing.
Mm-hmm.
So as far as unit testing go, knowing what to test for is like usually the software engineer knows that, but building the workflow and like building the sort of automated unit testing might be more of a DevOps sort of thing. What would you say is like I guess how those intersect? What do you think I should learn to be able to do unit tests effectively and like cleanly in a good way?
I think knowing the environment that your code is going to be run in, because workflows are really good at replication, so it's really good at replicating the environment that you're trying to create. And really, it's pretty simple. You can use Docker. I think it's easier on like containerized services, but using your workflow, I guess it's just the skill comes in replicating that setup. Because once you can replicate that setup, your workflow already has access to all the code you're trying to push, and then it just comes about to creating some sort of script of the things that you want the code to be able to do, and then being able to run it from that environment. So I really think the only issues you're going to encounter on that is when you start to work with more complex infrastructure, because then replicating that infrastructure for your tests is sort of that difficult part. Yeah? Any other questions? We're way over, and I'm glad no one just like dipped out. At least shows some sort of interest. All right. Well, thank you guys. I try to keep things simple, even though it didn't appear too simple and things failed. If you have questions or look at the notes later on and have any concerns about it or want to replicate it, feel free to reach out. If you're interested in more like advanced topics, my Discord is the one that posts the information about this, so just message me. I'm always open to answer questions. I love this stuff. I love doing it. Still getting better at it, obviously. It's a very hard thing to do, but I'm always open to talk to people who are interested in learning more about it. I would say Terraform and workflows, if you want to dive into it more, are always really good to know, and no matter what you do, especially workflows. Workflows. That is like the key. Otherwise, you're going to bang your head against a table when you start pushing code. All right, well, thank you guys. Appreciate you for coming, and yeah.